Hello, and welcome to Agrosive Physics. Today is day 135. And what I'd like to do today is discuss the quark. Now, originally, the atom was believed to be the smallest particle, and that's why it's called the atom. In fact, the Greek word atom means indivisible, so it's the smallest particle that the Greeks believed was possible. Now, ultimately, we determined that there were smaller pieces that made up the atom, and we call those subatomic particles, so smaller than the atom. And that was the electron, the proton, and the neutron. And over the past 50 years or so, we found that those are broken down into even smaller pieces, and we call those the quark. Now, quarks are what we consider to be the smallest particle at this point. It doesn't mean they are. It just means that that's the smallest we've been able to determine up till now. And there are 6 different types of quarks. They make up all the bigger particles. For example, a proton is made up of 3 of the quarks. A neutron is also made up of 3 quarks. The types of quarks have a weird name. They're called flavors. So we have 6 flavors of quark. And they are up, down, charm, strange, top, and bottom. And each one has a fractional value that represents their charge. So quarks don't have whole charges like protons and electrons do. They have a combination of a fractional charge. Now, proton is made up of an up, and a down quark. Now, up quarks, charm quarks, and top quarks are all 2/3 of a charge, positive. A down, a strange, and a bottom are all negative 1/3. So if we have an up, and a down quark, that adds up to +1, which is the proton. A neutron is an up and a down, quark. An up is 2/3, and 2 downs are -1/3 and -1/3, which is neutral. So we could figure out, based on the number of quarks or the types of quarks, what the total charge is on whatever the particle is. And assessments will often give you an unknown particle you've never heard of, and they tell you it's made of this set of quarks. And all you have to do is be able to add fractions. Now, as far as our reference table goes, what we have is a chart that lists the quarks by their symbol. Up is a U, charm is a C, top is a lowercase t, down is a D, strange is an S, and bottom is a B. And then it also lists their charges. So it's 2/3, 2/3, and 2/3, -1/3, -1/3, and -1/3. And those are all based on the elementary charge, which is 1.6 × 10 to the -19 coulombs. So it's 2/3 of that, or -1/3 of that. So these quarks make up all the bigger pieces of the puzzle that we know about. And we're still discovering newer and more cutting-edge particles as we use particle accelerators even today. So there are a number of particles that are being found constantly. For the state assessments, though, we're responsible for knowing about the types of quarks, the flavors, if you will, what they're called, and their charges. And if you need to add up a number together, you're going to be able to do that using fractions. So at this point, we know that the subatomic particles, the electron, the proton, and neutron, are not the smallest building blocks anymore. Quarks are. Who's to say they're the smallest? I'm not going to say that today, because it could be you that determines what makes up a quark, and it's even smaller than that. That's it for today. We'll do a couple of sample problems on the whiteboard. But otherwise, quarks are today the smallest building block of matter. All right, as our scientific knowledge increases over the years, we're able to find more about nature. And one of the things that we found in the last century or so is the fact that particles of the proton, neutron, and electron are not the smallest building block of matter. Quarks happen to be smaller than that. So quarks make up the bigger things like the proton and the neutron. So what we have are smaller building blocks, and we call them quarks. And the quarks have what we call flavors. We have up as a flavor, down as a flavor, charm as a flavor, strange as a flavor, top, and bottom. So there are 6 different types of quarks that make up matter. And the reason I list them like this is because that's how our reference table lists them. They have the quark and their symbol, which happens to just be the letter, the first letter of each, so U, D, C, S, T, and B. And then it lists the charge. So an up quark is plus 2/3 E. A charm, plus 2/3 E. A top, plus 2/3 E. And this is why they're listed there. A down, negative 1/3 E. Strange, negative 1/3 E. And bottom, negative 1/3 E. Now what's the E? Well, it's the elementary charge, which was 1.6 times 10 to the negative 19 coulombs. So this means that the up charge is made up of a portion of the elementary charge. Now, if you can add fractions, you can do most of the problems that you'll be asked to solve on an assessment. For example, a proton, we now know, is made up of 3 quarks, an up, and a down quark. Now, what would be the total charge of a proton? Well, we know a proton's plus 1. So let's see if that works out mathematically. Up is plus 2/3, up is plus 2/3, and down is minus 1/3. And since these all have the same denominator, it makes it kind of easy to add together. 2, 2, minus 1. 2 plus 2 is 4, minus 1 is 3. So plus 3 over 3, well, proton has a charge of plus 1. On the other hand, a neutron is an up, down, down. All right, up is plus 2/3, down is minus 1/3, down is minus 1/3. 2 minus 1 minus 1, 0. So the neutron is neutral. So quarks can be used to determine the charge of particles, such as the proton and neutron, or if you're given a particle that may have just been discovered in the last few years, because more particles are being discovered, it seems almost daily at this point, they'll tell you what quarks make up that particle, and you can determine the value of the charge. On the other hand, you can determine whether or not a quark combination could be what makes up a particle that has a plus 1 charge or something like that. And you'll have different choices, maybe up, charm, strange. Well, that could be a plus 1 charge. It's not a proton, we know it's up, up, down, but it could be another particle that has the same charge as the proton. So quarks are even smaller building blocks of matter than the subatomic particles. So this is a subatomic particle. And they each have a part of a charge related to the total elementary charge, which we originally believed was the smallest charge that we can have. So these are partial charges. They do add up together to make the plus 1s and the 0s, but they themselves have partial charge. At this moment, quarks are as small as we know. It doesn't mean that they're the smallest particle. It's just the smallest that we can observe now. So that is how quarks work. Different flavors and different charges.